is GRE? GRE stands for Generic Routing Encapsulation. It is point-to-point VPN, or you can say site-to-site VPN. Means we are creating a virtual network between 2 points. 2 points can be hub and a spoke 1, or it can be a spoke 1 and a spoke 2, or it can be a spoke 2 and a spoke 3. Now we have multiple mode of GRE. By default, when you are creating the tunnel, like I'm running command interface tunnel 1, right? So tunnel mode is by default GRE. But guys, we have another mode of GRE as well. Like we can configure GRE mode multi point to multi point, or I can configure point to multi point. So see, in this scenario, if I want to configure VPN something like this, like one point should be connected with multiple points. So this is what this is, point to multi-point GRE. And in DMVPN we are going to use this mode of GRE only. So first of all, why we come up with DMVPN? So the issue with GRE is need to create multiple tunnels in the headquarter as well as at the branch offices. If we have 100 branches, then we need to create 100 number of tunnel on headquarter on this router. So automatically load will increase over here. Your CPU utilization can increase, because of that performance can reduce. So to connect 100 sites, I want to create only one tunnel here. I want to create only one tunnel here on the headquarter. That's why we come up with DMVPN. This is the issue with GRE. And guys, two spoke cannot communicate directly until and unless you will not configure GRE between them. They will communicate via headquarter. So these are the issues with GRE. Right? That's why we come up with DMVPN. So if you have 2 side or 3 side, you can go with GRE, no problem at all. But if you have multiple side, like 100 number of side, 1000 number of sides, then you will go with DMVPN. And DMVPN is combination of two things. Like your normal VPN is nothing but the GRE configuration, GRE tunnel, right? But the DMVPN is combination of two things. Here we are going to use GRE as well as one protocol, right? So hope why behind DMVPN is clear, like why we come up with DMVPN. Then it is combination of GRE as well as, let me write here, GRE and a protocol. Which protocol? Anyone have idea? NHRP protocol. NHRP protocol. Now why we need NHRP protocol? Soon you are going to understand this. First try to understand the GRE. Guys, yesterday what I told you, that whenever exit interface is the tunnel interface for traffic, then router will encapsulate the actual information in GRE header, right? Like if my PC is generating one ICMP packet, ICMP. So ICMP works at layer 3. So this protocol, ICMP protocol, will generate ICMP request message at layer 3. Then ICMP protocol will hand over the actual message to IP protocol at same layer. IP protocol is going to add what? Source IP and destination IP with this actual information. Source IP will be the IP address of sender device. It can be 10.1.1.1, and destination IP will be the IP address of destination device. Let's say 20.1.1.1. Then it will hand over to lower layer, means to data link layer, and data link layer is going to add the source MAC and destination MAC address. And after that, device can hand over it to physical layer. Physical layer will forward it from the link. It will transmit the data on link. So source MAC 0A, destination MAC, let's say 0B. So see, if this router 1 is receiving this traffic, R1 will simply compare destination IP address with your routing table, and then it will forward the traffic. But if the exit interface is not the physical interface, if exit interface is tunnel interface, then router is going to add one extra header. Where? Here, between layer 2 and layer 3 header, right? And guys, in the extra header, what information will be there? This is GRE header, right? Here in the extra header, it will add the tunnel source and tunnel destination. Tunnel source IP address which you have defined in the tunnel, and tunnel destination. Correct? And ISP, internet router, is going to check this header, right? The outer header, to forward the traffic. So in the outer header, source IP is also public, destination IP is also public, means internet router can forward this traffic. Inside the internet, there will be lots of routers. Lots of routers will be there, and all routers will forward traffic on the basis of this public IP address, right? ISP routers are going to only open this header. But when your spoke router, this router will receive the traffic. First, it will again check this header. In this header, destination is 2.2.2.1. 2.2.2.1 is, let's say, IP address of spoke 1. Then it is going to check the GRE information. What informations are there under GRE? So they will say the protocol. Protocol field will be 47. Then it will check GRE, means tunnel interface is there or not. If tunnel interface is there, GRE protocol is working there, then it will hand over to GRE protocol, generic routing encapsulation protocol. And GRE protocol is going to open actual this header. This is how router process the traffic on the tunnel interface. Correct? 1 minute, I'm getting one. Yes, guys. So the GRE encapsulation will work same in DMVPN also, and in point-to-point, side-to-side VPN also. But in DMVPN, we cannot define the tunnel destination. Will not define the tunnel destination. The reason, guys, see, if I am adding one new branch over here, right? So here I have to configure what? tunnel source, tunnel destination. And here also I have to configure what tunnel source and tunnel destination in GRE. I'm going to create one extra, one more tunnel, right? One more GRE. And tunnel source, tunnel destination is required both side, on in headquarter also and in the new branch office also. But in the multi-mode will not define the tunnel destination. Then how this device sites or the headquarter will get to know about the tunnel destination IP address? With the help of protocol. With the help of protocol. Which protocol? NHRP protocol. We can define tunnel destination IP address only on side-to-side VPN. Only on side-to-side VPN, point-to-point GRE you can say. Because in point-to-point, one point is connected with another point. But in DM VPN, one point is connected with multiple points. In DM VPN, one point is connected with multiple points. Okay, so GRE can be point to point, GRE can be point to multi-point, or GRE can be multi-point to multi-point. If one point is connected with one another point, that is point to point GRE. If one point is connected with multiple point, that is called point to multi-point GRE. And if multiple point is connected with another multiple point, that is called multi-point to multi-point GRE. So in DM VPN we are going to use which mode? These are mode of GRE. These are mode of GRE. And in DM VPN we are going to use point to multi-point, or you can say multi-point to point GRE. Like guys, here in this scenario, on router number 1, interface F0/0 NoCert and IP address 100.1.1.1 done, and do ping 100.1.1.2. Let me check, am I able to ping the internet? Yes, I am able to ping internet. And on router number 2 also let me configure one public IP address, interface F1/0 say NoCert, and IP address 101.1.1.1 255.255.255.252 and do ping 101.1.1.2. Right? Now these two public IP addresses are reachable with each other. The only thing is I need to configure default route. So on router number 1 I am going to configure one default route towards ISP IP.0.0.0 0.0.0 and 100.1.1.2. On router number 2 also IP route 0.0.0 0.0.0 and 101.1.1.2. Now I can configure the tunnel because both public IP addresses are reachable with each other. 100.1.1.1 sorry 101.1.1.1 and see ping is working. I am able to ping remote public IP address. Let's say router 1 is in India, router 2 is in US, right? Both are connected with internet. From the ISP, both sides I have purchased one public IP address and both public IP addresses are reachable with each other. So now I can create private network. I can create the tunnel. So interface tunnel 1. The important thing is here I have to configure tunnel source, tunnel destination. And tunnel source will be the IP address which will be encapsulated inside GRE header. Tunnel destination will be the the destination IP address in the GRE header, right? So tunnel source, here even I can use fast Ethernet 0/0, because let's say my IP address is dynamic, not static, then you will use the interface like this. But in GRE we cannot use dynamic IP address. Here I have to purchase a static public IP address. The reason, guys, on order number 1 I am going to define the destination IP address. Tunnel destination 101.1.1.2, and then IP address 10.1.1.1 255.255.255.252, and do so interface brief. My tunnel interface is up. Debug IP ICMP, and I am going to ping which IP address? 10.1.1. Let's say 2. What happened? So IP route. So 10.1.1. directly connected this network contra interface. It should encapsulate one packet, ICMP packet. So IP interface brief. Yeah, tunnel interface is up. Let me do one thing on router number 2 also. I'm going to create the tunnel interface tunnel 1 and IP address 10.1.1.2 255.255.255.252, and tunnel source fast Ethernet 1/0 1/0, and the tunnel destination is 100.1.1.1. Tunnel destination. Wait a minute, let me troubleshoot it. What happened here? So IP interface brief, tunnel interface is up, so run interface tunnel 1, 100 correct on router number 1, so run interface tunnel 1 252, that is fine. That, sorry, tunnel destination is incorrect. Interface tunnel 1 and the tunnel destination is 101.1.1.1. Now on order number 2 I am writing .1 here, the remote public IP address, right? So guys, here in debugging it's showing source IP address, the IP address of your tunnel, but on the internet if you will capture the traffic you will see sources, the IP address which you have defined in on the tunnel interface, like tunnel source IP address, and tunnel destination IP address will be the tunnel destination IP address. After the GRE header, right? So here for the clarification we can capture any link F0/0. Yeah, and now again I am going to ping. See the ICMP packet. Let me open anyone. See, the actual message is this one, ICMP packet, right? Then the actual IP header, after that there is GRE header, right? And then guys we have new IP header, and in the new IP header source IP address is public, destination IP address is public. The source IP address is the IP address which I have configure as tunnel source, and the destination IP address is the IP address which I have configured as tunnel destination, and then there is layer 2 header. So ISP, internet routers, are going to check this header only, right? Internet router will not open GRE header. It will only check this destination. This destination is public IP address, means it will be reachable, and on the basis of this IP address, ISP router will take forwarding decision. Only destination router is going to check this header. The reason, destination is, guys, 101.1.1, right? So who will open this packet in detail? Only 101.1.1.1, right? The router who is using this IP address will open it in detail. Right? And this VPN is overlay network. This VPN is overlay network, guys. This is your physical network, correct? So this physical network is underlay network. Underlay network means your basic IP connectivity. And over this underlay network, we have created this tunnel, this VPN, virtual network. So this is my overlay network. Overlay network. Right? So we have created the overlay network, but overlay network is forwarding traffic through the physical network only, through the underlay network only. So if, let's say, any router on the internet will goes down, your overlay network will goes down. Like VPN or DMVPN, these all are what? Overlay technology. Your SD-WAN, these are what? Overlay technology. So where I am creating this overlay network, guys, over internet. So this VPN, you can create this VPN over any WAN circuit. It can be internet, it can be MPLS, it can be LTE, 4G, 5G, it can be broadband, right? On any WAN circuit, I can create this VPN. The requirement is the public IP reachability, right? This is not only for internet. Even, let's say, in my company, guys, there are some routers, like let's say there are 9 building, 10 number of building. At each building we have one router, R1, R2, R3, R4, R5, R6, like this. Let's say 6 buildings are there, correct? Here I have one LAN 10.1.1.0/24. Here I have one LAN 20.1.1.0/24. So between router 1 and router 2 also I can create one VPN, right? With the help of what? IP address over here and over here. If these two IP addresses are reachable with each other, then I can create VPN. And through this VPN, I can exchange these routes. So here also between branch 1 and branch 2, why I have created this VPN? I have created this VPN to exchange these routes. Right, guys? So on this tunnel interface, now I can configure the routing protocols. I can configure OSPF, I can configure EIGRP, I can configure RIP, I can configure BGP, I can configure ISS, any routing protocol I can configure. And with the help of routing protocol, we can exchange these routes. Let's say in side 1, this is side 1. In side 1, I have 100 number of prefixes. In side 2 also I have 100 number of prefixes. So we can exchange these 100 number of prefixes through this VPN. And for all communication, internet routers will only see the tunnel source, tunnel destination in the header, in the IP header. Right? So sometime interviews it also ask you this question, like what is overlay network? Is VPN overlay or underlay? Right? So VPN is an overlay technology. Underlay means your physical network. And guys, whatever overlay technology we are using, that is based on the physical underlay network only, the basic IP connectivity. If the physical network will goes down, then my automatically overlay network will goes down. In the today's world, we are using SD-WAN, right? SD-WAN, as I told you, is an overlay network. Why, guys? Earlier we have not any technology like this. The reason, earlier the WAN circuit was not reliable like how reliable it is today. Today's internet is reliable. So even we can connect two sites like this. Done. And in real time, see here you have only one connection between side 1 and side 2. You have internet. So guys, if internet will goes down, then connectivity will goes down. So in real time you will have multiple connection. This can be like ISP1, right? You can have one more connection here, let's say ISP2, right? Or it can be another connection like MPLS. Right? And on all the circuit, on all the WAN circuit, you are going to configure VPN. You are going to create virtual network on the MPLS also, on the internet also, on any WAN circuit. Done. Now in DMVPN, see, for the DMVPN, I think I have one topology. Let me check in just a minute. GNS task. Six VPE. These are the MPLS. Here is the DMVPN. Done, guys. This is the OSPF deployment. Leave the OSPF mode. Or it will be better. Let me do one thing. We can create one topology as well. This is spoke 1 means branch 1, spoke 2 branch 2, and this is my, let's say, headquarter. Fine, let me turn on these devices. So I'm going to use this subnet on the tunnel interface. See guys, on the hub router, what I will do, I will configure, see hub, this point, this interface is connected with multiple point like branch 1 also, branch 2 also. So here I am going to configure GRE mode multi-point, and here this interface is connected with only hub router, right? So here I am going to configure point to point, GRE mode point to point. And on GRE mode point to point, you can configure the tunnel destination, but you cannot configure tunnel destination on multi-mode GRE, because multi-mode means this point is connected with multiple points. So there is not one destination. So we cannot define the destination. We will use the protocol. Which protocol? NHRP protocol. And in NHRP, we have two types of router. NHRP stands for Next Hop Reachability Protocol. It is a layer 3 protocol used in DMVPN. Soon you are going to understand the use case of NHRP, but there are two types of routers in NHRP protocol. So one is, guys, NHS and second one is NHC. NHS means next hop server and one is next hop client. So your hub router is going to become NHS server and all the spoke routers is going to become NHC client. And the client routers are going to register themselves on server. Means these spoke routers are going to register themselves, will share their IP address. See, their public IP address will be what? Destination IP address. For router 1, for this tunnel interface, destination IP will be what? The IP address of this interface. So we'll configure the NHRP protocol, NHRP. Through NHRP protocol, this spoke router is going to share their public IP address. That, bro, my public IP address is 2.2.2.1. Right? In the same way, spoke 2 will also share their public IP address. So all NHC is going to register themselves on NHS. While configuring, I will explain these all things. Just wait a minute. Here, let me access the routers. I'm going to stop this topology because this is simple GRE, and hope you are now able to configure the simple GRE, point-to-point GRE. It's easy. See, I am running EVNG on my local PC nowadays. The reason, guys, I am out of station. So that's why it is chance that my laptop can get hanged. So it is better to use GNS3. Yes. Hub router, there is already some configuration, so I am going to erase startup configuration and then I can reload the router. See if it will work. Otherwise, what I will do, I will remove this router, I will change the router, right, so that we can configure everything from the scratch. Yeah, do one thing, let's replace the routers here also, and this one also. This is my hub router, means hub means headquarter router. This is spoke 1, and this one is spoke 2. Try to understand very carefully, guys. This is very important. Fast Ethernet 0/0, 1/0 to this interface, and over here. Yeah, let me turn on these devices now, and now I am going to access these routers. R1, spoke 1, spoke 2, and the ISP also to identify the subnet. So IP interface brief. See, the public IP address on Fast Ethernet 0/0 is 11.1.1.2. So run interface f0/0. What is the subnet? I am using /30, right? So here my subnet is 11.1.1.0/30, and I am running .2 on ISP side, means I will configure .1 on ISP side. Then, guys, on f0/1, which is connected with spoke 1. I am running 22.1.1.2. So 22 subnet I am running over here, and 33 I think over here. 33 f1/0. Yes, 33.2. Now let's start configuration from hub router. Config t interface f0/0 IP address 11.1.1.1 255.255.255.252 exit. Let me create one loopback here, interface loopback 1, which is my LAN network, right? 10.1.1.1 255.255.255.0. You can like connect one switch behind this router and then some PCs. Instead of connecting switch then PC, I am just creating one using one loopback. Even I can use configure one more loopback, loopback 2. Here I can say IP address 10.1.2.1 255.255.255.0. 2 loopback is sufficient. Then guys, I need to configure one default route here, IP route 0.0.0 0.0.0 exit interface f0/0 and next hop IP 11.1.1.2. Now I can ping to internet, do ping 11.1.1.2. Ping should work. What happened here? Let me run do so IP interface brief command. Interface is down. Yeah, this interface is down. So interface f0/0 say no set. No set, right? And now you can ping. This time ping should work. Right, ping is working. Now I spoke 1. Config t interface f0/0 IP address 22.1.1.1 255.255.255.252 and no set exit interface loopback 1 IP address 20.1.1.1 255.255.255.0 exit IP route 0.0.0 0.0.0 exit interface f0/0 and next hop 22.1.1.2. Done. On a spoke 2 config t interface f0/0 no set and IP address 33.1.1.1 255.255.255.252 exit interface f0 loopback 1 and IP address 30.1.1.1 255.255.255.0 IP route 0.0.0 0.0.0 f0/0 yes f0/0 and 33.1.1.2. Now I have configured default route on all the router. I'm not going to configure anything on internet router, so let me close the console. Now guys, from hub router, from the my headquarter router, I am going to ping the public IP address of spoke 1 and spoke 2 22.1.1.1 and ping should work because I have already configured default route on all the routers, right? So all public IP address will be reachable with each other, and you can see I am able to ping. Even I can ping to site 2 branch 2 means 33.1.1.1 interface is up. So IP route 33.1.1.2 ping 33.1.1.2 not able to ping 33.2. 33.2 is reachable. Yes, see I'm able to ping all sites. So now I can create the tunnel. I can configure the VPN. So let me do one thing. Let me create one tunnel over here, interface tunnel 1. And guys, on the tunnel C, I am going to use this subnet 192.168.10.0/24. So say IP address, 192.168.10.1 over here, 255.255.255.0. Then tunnel source. Tunnel source will be fast Ethernet 0/. Zero, right? Or I can configure 11.1.1.1. Yes or no? Then tunnel mode. See, by default tunnel mode is GRE. By default tunnel mode is, guys, GRE. That's why you can run command tunnel destination. But here I am going to change the mode. This point is, this tunnel is connected with multiple tunnel, right? Multiple points. So I am going to say multi mode, then I think GRE, and then multi point. By default this command is running. Tunnel mode GRE, right? So multi-point. Now here I cannot configure tunnel destination. Tunnel destination, if I am saying, let's say 22.1.1.1, see what it's saying. Tunnel destination configuration failed on tunnel 1 interface because mode multi GRE, right? Because now this tunnel interface can have multiple destination, so we cannot configure tunnel destination. So instead of tunnel destination, I am going to enable NHRP protocol here. And to enable NHRP protocol, you are going to run command IP NHRP and the network ID. Let's say network ID 1. Network ID is like process ID in OSPF. We can configure multiple NHRP protocol on single router. So that's why we have what? Network ID to differentiate the NHRP protocol, multiple NHRP protocol. That's it. This is a configuration of hub router. So what is the difference in terms of configuration between point to point GRE and multi-point to point GRE? The tunnel mode and NHRP protocol. Do so run interface tunnel 1. Tunnel 1. So see, I have configured the IP, I have defined the tunnel source IP address, then I have defined the tunnel mode, and then I have enabled the NHRP protocol. Automatically it have applied one command, that is no IP redirect. We'll discuss this command later. Now I am going to configure tunnel on spoke 1. So again interface tunnel 1, here IP address 192.168.10.2 255.255.0. Then tunnel source. Tunnel source is fast Ethernet 0/0. And here tunnel destination. Here I can define the tunnel destination because by default mode is GRE. GRE point to point, you can say. So tunnel destination will be what, guys? 11.1.1.1. Right? So means on all spoke sites, we are going to define the tunnel destination. Tunnel destination will be the headquarter IP address, public IP address of headquarter. Right? This is point to point, yes. Which mode of GRE here we are using? Indian VPN, multi-point to point. Multi-point to point GRE. Or we can have multi-point to multi-point GRE as well. When we want direct communication between two sites. Here, when we want to form dynamic tunnel over here, in that scenario, we will change the tunnel mode here as well, right? For now, it is point to point. Then now R3 spoke 2 config T interface tunnel 1 IP address 192.168.10.3 255.255.255.0. 0, then tunnel source fast Ethernet 0/0, and tunnel destination 11.1.1.1. On spoke 1, I need to enable NHRP protocol. So here I need to enable NHRP protocol as well. IP NHRP network ID 1. On this router also IP NHRP network ID 1. I have enabled NHRP protocol on all the router. I have created the tunnel. Now guys, can I ping the remote tunnel interface? Ping 192.168.10.2. Will ping work? If it is not working, then tell me the reason why ping is not working. Why I am not able to ping the remote tunnel IP address? Because hub router don't know what is the public IP address for this remote tunnel IP address, right? See, for this IP address, so IP route exit interface is what, guys? When I am pinging to this IP address 192.168.10.2, right, it will check the routing table. In the routing table, route is available, and exit interface is tunnel interface. So if exit interface is tunnel interface, it will encapsulate in GRE. In the GRE, it will add what? Tunnel source IP address is 11.1.1.1. Then tunnel destination. Is tunnel destination available here? Nope. Right? So actually hub router don't know what is the NBMA address or public IP address of this tunnel, remote tunnel IP address. And same thing is happening for spoke 2 also. So we need to actually map the tunnel, remote tunnel IP address with their NBMA address, with their public IP address. The remote public IP address is called NBMA address, non-broadcast multi-access address. So we need to map tunnel destination IP address with remote public IP address. And guys, for mapping again we have two options. One is static. I can statically map it, like I can say interface tunnel 1, and then I can say IP NHRP 192.168.10.2, and then NBMA address, public IP address of remote side. What is the command here? (192.168.10.2) and 22.1.1.1. IP NHRP map command, then 192.168.10.2, and then I can define the NBMA address. You can see NBMA address. NBMA address is nothing but the remote public IP address, which is 22.1.1.1. Like this I can map it. Or guys, I can use the protocol. Which protocol? NHRP protocol. So we can configure this router as NHS, as I told you, server, and these routers as a client. So client routers will register their self on server, right? For now, do so IP NHRP mapping. So IP NHRP. So there is no any mapping, you can see. There is no any mapping, right? But if I will map like this, interface tunnel 1 and then IP NHRP map 192.168.10.2 with 22.1.1.1. So if I will map this IP address, this public IP address with this tunnel, remote tunnel IP address, here you can see the output. So IP and HRP, there is one mapping, right? There is one, guys, mapping. This is the remote tunnel IP address and this is the NVMe address. This is a static mapping. Now can I ping to the remote tunnel 192.168.10.2? Yes, now you can ping. The reason, this time my hub router can encapsulate the GRE header. It have NVMe address, it have the public IP address of this IP address. So always keep in mind, whatever route will be there in the routing table of this router and exit interface is tunnel interface. For those all, this router need tunnel source and tunnel destination. Tunnel destination is NHRP NVMe address is the tunnel destination IP address. In the same way, guys, here we have to configure, we have to map NVMe address of spoke 2 also. So interface tunnel 1, then IP NHRP map 192.168.10.3 and 33.1.1.1. So IP NHRP. See, mapping is there, so I can ping to 192.168.10.3 also now. Ping is working. Now to exchange this route, I can configure routing protocol or I can configure a static route. If anyone don't have idea about the routing protocol, don't worry. See, here I can configure router EIGRP, let's say S number 10, and then I am running network 192.168.10.0. This command will enable EIGRP on tunnel 1 interface, and then I am going to advertise 10 network 10.1.1.0, which is my LAN network in EIGRP. Then say no auto summary. So IP EIGRP interfaces. So EIGRP is enabled on these all interfaces. Even you can check debug IP or debug EIGRP packet hello. So you will see router is sending hello message, right? It is sending hello message from the tunnel interface. So once I will enable EIGRP on spoke 1 and spoke 2, it will form neighborship. And guys, once it will form neighborship, it will start exchanging routes. Router EIGRPS number 10, network, I can say 192.168.10.0 and 20.1.1.0. No auto summary. Soon here we will have EIGRP neighborship. So IP EIGRP neighbor. So IP EIGRP interface. EIGRP is enabled on tunnel interface as well as on loopback 1 interface. It will form the EIGRP neighborship. No, it will not form the EIGRP neighborship. Reason, guys, see, I have enabled EIGRP on spoke 1, right? So it will send hello message on the multicast address. It will send hello message on the multicast address. It will send hello message on the multicast address, and there is no NVMe address available for the multicast address. Again, the issue. From the tunnel interface, it will send hello message on multicast address, but whenever exit interface is tunnel interface, that time it need what? NVMe address, but there is no NVMe address available. Debug EIGRP packet hello. Okay, see, it is sending hello message from the tunnel interface? It is generating the hello message, right? But it cannot send the message from the tunnel interface. The reason it don't have multicast NBMA address. NBMA address for that multicast IP address. So here on router number 2, I have to run one command, or I can run one command on hub router. Here I can say I can convert the multicast address into the unicast address. I can manually tell to the router, please don't forward the multicast hello message to spoke 1 and spoke 2. Please send the hello message on 22.1.1.1 and 33.1.1.1. How? Interface tunnel 1, and then I can say IP NHRP map. This time I am not going to map one IP address, I am going to map multicast. Multicast to, see, neighborship is fluctuating, guys. Neighborship is coming up, then again going down. So I can say map all the multicast packet into 22.1.1.1 and 33.1.1.1. Now it will start converting multicast into unicast, right? It will send the hello message to this IP address and to this IP address. Do so IP EIGRP neighbor, and now you can see we have EIGRP neighborship, and so IP route EIGRP, and now it have learned the 20 subnet. Even on the spoke 1, so IP route EIGRP, it have learned these two subnets, and now these two sites can communicate with each other. Ping 10.1.1.1 source 20.1.1.1, ping is working. In the same way on hub router, here hub 2 router EIGRP S number 10 and network 192.168.10.0 and network 30.1.1.0, no auto summary. Here also we have neighborship, so IP route EIGRP, you can see it have learned the subnet of headquarter and it can communicate. But why this router don't have route for the remote side? Don't have 20 subnet, right? This is just because of split horizon, right? Because see, from where it is learning this subnet, guys, from the headquarter. So spoke 1 will advertise these prefixes to hub router, and hub router need to advertise those prefixes to spoke 1, but by default split horizon is enabled. So a split horizon rule means do not forward the received route from the same interface, correct? Guys, here actually my tunnel is like this. One tunnel here, same tunnel is connected with this port. This is my overlay network, correct? This is my overlay network. Here IP address is 192.168.10.1. Here IP is 10.2. Here IP is 10.3. This is my overlay network, DMVPN. And here on this overlay network, I am running EIGRP routing protocol. So router 1, this router spoke 1 is advertising this submit to R1 on this interface. So it will not advertise same prefix from the same interface. What I can do, I can disable split horizon. On hub router, I can say interface tunnel 1 no IP split horizon for EIGRPS number 10. Now go to again spoke 2 and check the routing table. So IP route. Now you can see we have 20 subnet as well. Now I have 20 subnet as well, right? So can these two sites, two branch offices communicate with each other? Source 30.1.1.1. Yes, ping is working. Trace route 20.1.1.1 and source 30.1.1.1. See, traffic is going via headquarter. One minute. Done. Now what is the problem here? Issue is these two sites will communicate with each other via headquarter router, right? So load on headquarter can be high. This is DM VPN phase 1. This is DM VPN phase 1. In phase 1, we are configuring both GRE mode multi-point and point to point. On hub router, we are running GRE mode multi-point, and on spoke routers, I am running GRE mode point to point and NHRP protocol. See, here I have mapped the IP address on the hub router statically. Interface tunnel 1 and do so run interface tunnel 1. I can remove, sorry, do so run interface tunnel 1. These two command. This is for multicast mapping, that is fine. These two command. This is static mapping, right? As I told you guys, we have another option, that is dynamic mapping. So I can, yeah, yes, correct. So in the dynamic method, what we will do, we will tell to spoke routers that your server is hub, server IP address is this one. So it will send request to the hub router. And when hub router will receive the request, it will send the registration message and it will map the IP address. So in DMVPN phase 1, we have what issue? The sites. The spoke branch cannot communicate directly. They have to communicate via hub router. That's why we come up with DMVPN phase 2. In DMVPN phase 2, what we will do? We will configure here also GRE mode multi-point. On all the routers, we are going to configure GRE mode multi-point. That means spoke 1 and spoke 2 can also form one tunnel. Right? If I will talk about the tunnel overlay network in DMVPN phase 1, so it is like this, guys. It is like this. So here you can see all the communication will happen like this between spoke 1 and spoke 2, right? Because there is no connectivity here, right? But if I will talk about DMVPN phase 2, so in DMVPN phase 2, it is going to be like this. Right? So in this time, it can forward traffic to hub router like this, and they can forward traffic to other branch offices like this. Got it? Means here also we will have dynamic tunnel. Here both router will form dynamic tunnel. Okay, let me try to here configure the dynamic mapping once. I think it is not working in the simulation, but let me try. Say no to this and no to this, right? So IP NHRP, there is nothing, right? And on a spoke 1, so IP NHRP, spoke 2, so IP NHRP. In phase 2 you have to change it. In phase 2, now I am not configuring phase 2, just I am trying to dynamic mapping, right? So for dynamic mapping I can say here interface tunnel 1, not here on the spoke 1 config t, interface tunnel 1 and IP NHRP NHS. And guys, here we are going to define the IP address of my hub router, right? So NHS IP address 192.168.192.168.10.1. So can this router forward traffic to this IP address? Yes, because this router have the NVMe address of 192.168.10.1. You have manually defined the tunnel destination, right? So before running this command, I would like to capture this link. Before that, there is some captioning. Let me close it. Yeah. Sorry, yaar. By mistake, I have closed the GNS3 topology. Okay, no problem. The difference is only we need to run this command, guys. Here, also we will hit enter over here. What will happen? This router will send one request message, NHRP request message to hub router, right? In the request message, they will share their NVMe address, their public IP address 22.1.1.1, right? And their internal IP address 192.168.10.2. On sort of one hub router will receive the request message, it will make one entry in their table, right? The remote tunnel IP address 192.168.10.2 and their NVMe address is 22.1.1.1. So this time this entry will be dynamic in nature. Earlier we had configured the static entry. This is the only difference. Done. Yeah, correct. Now until and unless you will not define the NHS IP address on spoke routers, these devices cannot communicate because now router 1 don't have NVMe address, right? So DMVPN phase 1 and phase 2. In phase 2 there is again no any difference. Only thing is here you need to change the GRE mode. On a spoke also you are not going to define tunnel destination, right? Simply you will set mode GRE multi-point. Sorry? No, I have lost the configuration, all configuration. I didn't save the configuration, so we have to perform IP configuration again. You can try it by yourself, bro. And guys, in DMVPN phase 2, again there is some issue, right? So we'll see that issue later. DMVPN phase 2 issue, then you will see why we come up with DMVPN phase 3. So we have total 3 phase in DMVPN. And after that, see, just I will configure any one routing protocol, like I have configured EAGRP, but you need to configure multiple routing protocol. You should try static routing, right? See, all routing protocols are working on the TRI interface or not, on the overlay network or not. Maybe in OSPF you need to run some extra command, like in EAGRP. Here I have disabled the speed horizon. And if you don't have idea about the routing protocol, then don't worry, right? Leave the routing protocol for now. Just try to understand the overlay connectivity, right? And guys, this is not only for internet, as I told you. This can be between any 2 point. It can be my private network as well. Like let's say within a city, I have multiple centers, right? And at each center, I have one route R1, like this, R2, R3, R4, R5, like road. You can assume the road, right? So road is connecting multiple cities together, like this. And between 2 points, let's say this point and this point, I want to create a VPN, right? Best path. That can be your overlay network, VPN, right? Here also we can create. So this overlay network is similar like your GPS navigation, right? Which will show you directly the best path between 2 points on the basis of traffic. So internal network, your physical network is like your road, and the overlay network, your VPN, is similar like GPS, which is the best path, right? Even in this scenario, see, we are exchanging routes. From router number 1, we are advertising some routes to this spoke router. So this internet router will not get those network information, because guys, routes are where? Routes are under EAGRP packet. Routes are under EAGRP packet. Here is the routes 10.1.1.0/24. And ISP's router are only going to check what? Extra header, where source IP is 11.1.1.1 and destination IP is 22.1.1.1. On the basis of this header, ISP routers are going to forward the traffic, right? So ISP routers are not going to open the actual actual EAGRP message. Only this router will open it and this router will learn these routes. But they can communicate. So this is the concept of VPN, overlay network, our inter, or you can say underlay network. Okay. So maybe tomorrow we will have again one session on the VPN for phase 2 and phase 3. After that we can run one more protocol here like OSPF or the BGP, right? All protocol will works fine guys over VPN. Then we'll see the VPN phase 3 configuration after that. Done with the VPN. So now here you can configure what? IPsec. See why I have not covered IPsec till now. The reason is guys you need to learn some basic fundamental of security like the SA. Do you know SA Security Association or leave SA CIA model, right? Once you will learn the security fundamental, it will be very easy for you to configure the IPsec over here. Through IPsec, we only need to secure it. The IP connectivity is still there. Only you need to secure it, right? So you can find the command. What is the command to configure the IPsec? Even you can download the PDF from Google for the command. Like I can say what IPsec, let's say on Cisco iOS PDF, and for you router LA will be best. So IPsec side to side VPN, right? See on Cisco iOS router. See if I will run this command here, right? Maybe you will not get it, like why you are running encryption DS or hashing AES, because now you don't know what is the AES or DES or what is the group or what is the lifetime or what is RSA signature. So before talking about the IPsec, you have to understand first basic security fundamentals. Like you know the basic fundamentals of routing. This is the reason why I am able to teach you VPN. In the same way guys, first of all you have to learn basic security fundamental like what is cryptography, what is crypto, ISACAMP. So just I don't want to make you confused brother, that's why I have not configured the authentication till now. Yeah, first we will have 2 to 3 session on the security fundamentals. After that I will tell you how to secure it, right? Till then if you want to secure it you can run these commands on your router, right? Even there is some explanation as well. Okay, and guys first try to understand the IP connectivity. This is very important, like how these two sides are going to share data with each other, right? Security is completely one another technology, how to secure it. Like in the IP connectivity there are lots of things, switching protocols, routing protocols, the IP addressing, subnetting, many things are there, right? In the same way many things are there in the security fundamental. And in your enterprises syllabus, like in your CCNP enterprise in core and NRC, right, there is only IPsec commands, right? So you will get how to configure it, but what it is you will not get it, right? So that's why what I will do, I will take 2 to 3 session for the basic security fundamental, and after that we'll configure the all authentication protocols, like the authentication in OSPF, authentication in the GRE, right, IPsec, all the things. right? So anyone have idea about the CIA model, guys? Confidentiality, integrity, and authentication. What is confidentiality? Access the data, right? Like you have $5,000 in your bank, so only you can access that money. That is what? No, no, this is incorrect definition. By the way, you can say yes, this is like only authorized person can access the data. This can be the example, right? If we have 5,000 in the bank, so only you should be able to access that. That can be confidentiality. Yes, we can say that only a authorized person can access the data. So in the network, example can be like the, let's say, server of Cisco should be accessible from Cisco engineers only, Cisco employees only. That is what? Confidentiality. But the question is how to achieve it. How you can achieve confidentiality, guys? How to achieve it? With the help of encryption. With the help of encryption. Like, let's say there is one data called hello, right? So I want only authorized person can access this data. So I can decrypt it, encrypt it first, encrypt it into, let's say, 1, 2, 3, 4. So what is happening over here? I'm using one algorithm. In that algorithm, H is encrypted into 1, E is encrypted into 2, L is encrypted into, first L is encrypted into 3, and second L is encrypted into 4, and 5 is here, and last O is encrypted into 5, right? So the people whoever have this algorithm can decrypt it, right? Now let's say there is no hello. I have, instead of hello, I am storing this information on my server, right? So guys, who can access this data? Only the people who have this algorithm, right? And I will share this algorithm with my employees, with the authorized person. Then we have I stand for integrity. Intri what is integrity? So these are the security fundamental. Don't worry. Now we are not going to discuss because this is not the security class. Even you will not find this type of concept in your syllabus, right? But there is IPsec. So sometimes don't know how Cisco have designed the syllabus, how people will learn it. Like there is Cisco DNA. Cisco DNA center in your syllabus, even in your CCNA syllabus. So here you don't need to learn the DNA technology, DNA center technology. You know, this is the syllabus for 3 months. And this is one topic in your syllabus, means you only need to learn what is DNA center, right? Means this is a controller which is used to manage, configure, troubleshoot the LAN devices, your access layer switches, your distribution layer switches. That's it. This is a part of SDN network, right? So IPsec is also exactly similar like this. You only need to understand what is IPsec, what is IPsec, how to secure the GRE tunnel. You don't need to go into deep. For the deeper, definitely you will go for security course, right? Where you are going to master the security fundamental, then you are going to master firewalls, right? You will go for ESA firewall, you will go for Palo Alto firewall, different firewalls. And you know, security, learning security is more, guys, interesting than the routing and switching, than the enterprise.